Welcome to the third and final part of 4.1, Angles in Radian Measures. Our objective and essential question are still the same, so use the concept and notation of functions to interpret and apply them in terms of their context. And what's the difference between radians and degrees, and when is it better to use radians? So we're going to talk about arc length, the length of a circular arc. So if r is the radians of a circle and theta the non-negative, keep that part in mind, non-negative radian measure of a central angle, the length of the arc is interpreted by, so S is your arc length, equals your radians times your theta. So a circle has radians of 6 inches, or radius of 6 inches. Find the length of the arc intercepted by a central angle of 45 degrees. So we want to express the arc length in terms of pi and then round our answer to 2 decimal places. So first thing you want to do is convert 45 degrees into radians. So if you remember, you have to do your 45 times pi radians over 180. So we have pi over 4. Now, arc length equals radians times theta. So we have 6 times pi over 4. And this is in inches. So it says express it in your pi, so that's here. But now we want to convert it to 2 decimal places. So once you plug that in your calculator, you should get about 4.71 inches. And that's your answer. So your arc length is about 4.71 inches. So here you have 2 different definitions here. Definition of linear and angular speed. If a point is in motion on a circle of radius r through an angle of theta radians in time t, then its linear speed is v equals s over t. And your arc length is s equals radian times theta, and its angular speed is your w equals theta over t. Linear speed in terms of angular is v equals rw. The w is your angular speed. We're going to do we're going to do an example here. So long before iPods that hold thousands of songs and play them with superb audio quality, individual songs were delivered on 75 RPM and 45 RPM circular records. A 45 RPM record has an angular speed of 45 revolutions per minute. Find the linear speed in inches per minute at the point where the needle is 1.5 inches from the record center. So before we can apply that formula, we need to express in terms of radians per second. So here's our W. Now you have 45 revolutions per 1 minute. We have to convert it into our radians. So you have 2 pi radians in 1 revolution. That's what she's saying. So you have 90 pi radians in 1 minute. Now you can go on and answer the next part. So we have 1.5, because it's 1.5 inches from the record center, times our 90 pi over 1 minute. So you have 135 pi, but we want to convert that, so you have 424 inches per minute. Make sure you complete your homework and come to live class.